Welcome to this short recorded video that will go over the Build Your Intuition activity, which is the first activity of the Part A lecture notebook for Module 6. So the purpose of this activity is to build your intuition about the performance of the training algorithm for the perceptron. For each part, you should try the code on different sets of training data with different sized gaps in the classes to make sure that your statements comments are actually correct. So I say you should be adding code and markdown cells below as you work through this activity, much more than what I have available here. So I'll just go ahead and start adding some code cells, and I'll switch some of them to markdown cells. Well, you should switch some. I'm just going to show you how to do the code. For different training sets with different gaps, I ask you to set the number of epochs sufficiently high. You often will find you don't need too many, so that the optimal weights and bias are learned. The optimal weights and bias are not unique. They depend upon the initial guesses and learning rates. For fixed initial guesses, I want you to comment on the sensitivity of the optimal weights and bias that are learned as the learning rate is varied. And for a fixed learning rate, I want you to comment on the sensitivity of the optimal weights and bias that are learned as the initial guesses are varied. So just to understand what I'm asking you to do here, you are going to be running, let's say this is with the gap data, that's for the 1D. So let's go to here, this training data. So here, when we call the training data with one guy, I'll run interact here. This problem. I'm asking you to just play around with this, where you're going to feed it X data and Y data that are generated by creating this data, and you change the gap, and you can also change the number of training data. So you should really just copy and paste this line of code, assuming all of this has been run. Let's create some different sets of training of some data for us to use. So I'm just going to create a few of these. I'm going to copy and paste them down, and we'll just call it, let's say, X data 1 underscore 1 underscore 1 underscore 2. I'm just going to do these first. Underscore 3. Let's say underscore 4 and underscore 5. So we're just going to do some different sets of data. Oh, that should be a 3. This will be underscore 4 and underscore 5. Now you need to change the gap. So you can just change the gap. It was 0.2 before. You can make it like 0.5, or let's say 0. Let's say how, I forget exactly how big I made the original interval here. The first point is 0.4. So if you go to 0.5, yeah, you don't go above 0.5, really 0.5, because at that point you have the next interval is going from 0.9 to 1 because you're taking 0.4 and adding the gap. So you don't want this to be too small. But 0.5 is a pretty good size gap. So let's say 0.5, that has a big gap in it. And then let's make a gap, let's say of 0.01. So it's a very small gap. And in fact, you can even make the gap to be 0. And I'll talk about that in a second, because you can say, well, you're supposed to have some sort of gap. There is essentially a gap there. All of these are using the default number of training data. So I'm scrolling up again. I scrolled too far, of course. And here we go, which is the number of training data is 100. So let's play with this, where we also make the number of training data different. So let's do num training equals, let's say, 10, which is significantly less data. And let's do that with, let's say, a small gap. And then let's also do the number of training data is 10 with a large gap. So I'll make this like 0.5. And then let's just go ahead and do the same. We'll create 2 more data sets. So I'll just copy and paste these. This will be 6. This will be 7. If I hit the right key on my keyboard. And then 6 and 7. And then we'll do, let's say, 1,000 training data. All right, so we're using an order of magnitude more, an order of magnitude more training data, an order of magnitude less training data, for at least these 2. And well, I'm actually I'll leave that here, and I'll just explain the 0, 0 here. So if you just run this will create all these different training data sets. Now, one thing is, the conclusions you might draw about things are probably going to change, because I'm not setting any random number generator here. So in order for all of it to be the same or reproducible, it's a good idea to set the seed here. So before I even, let's say, in this code cell, just to make sure everything is always going to work in the same way, I'm just going to go ahead and set a random seed so that all the data that I create here will always be the same every time I run this code cell. I recommend you do the same thing. So now I have that. So what I've done is I've created data that has different size gaps, and I have different amounts of training data in it. So this is a good test bed to then try to understand the sensitivity to all these questions. So now all I need to do, oops, I just pressed the F, okay, I guess I pressed the F key somewhere and I wasn't in an edit mode, so it was okay. So when I create this training data, after I create it, all I need to do to look at the visualize the updates of the 1D perceptron is this code here. So I'll go ahead and copy and paste that code. Probably a good idea to make these plots a lot smaller. You might want to adjust this fig size just to make it a lot smaller, but that's okay. I'll just go ahead and rerun things. So I would say create one here where I have x data 1 and x data 1. So this is with a large gap of 0.5 and 100 training data. All right, and you run interact and you see, so this is with one epoch, right? With these initial guesses, which you should also change. We see that it's learned, right? It's learned the right value in one epoch with that large number. If you increase this, so go to 93, 1.53 negative 1, watch, it won't change. Because it already learned it. Like as soon as you get something that works, it's fine. So that's what's happening there. This took one epoch. Now, what would happen if I played around with these weights and bias terms? I did initial guesses. Look, it's not the same values anymore. 2.43 and negative 1.6. That's not what we were getting before. Depending on your initial guesses, you're going to get these different numbers. Again, I think these are probably all learning in exactly one iteration. So if we do no epochs, right, here's the initial value. See, it's wrong. You're misclassifying because this is saying 1 here, and you have all this data that's at negative 1. If I go to one epoch, all right, let's do that. One epoch, and enter, there we go. One epoch. Sometimes if you don't press enter there, if you edit it directly, it doesn't actually change it. So with one epoch, there it is, 3.8, negative 1.7. And notice where it's at. It's like way over here as opposed to some of the other ones that were more in the middle. It's all going to depend on where these are and what happens if we drive the learning rate down. Make the learning rate, let's say 0.07, right? Now it's 3.86, negative 1.68. You go up to like 0.24, 3.83, negative 1.63. So how sensitive is it to this learning rate? It doesn't seem that sensitive with this size gap. And this is the big gap data, x data 1. You should run it with some of the others. So let's go ahead and see what happens when I run it on the data. I'm just going to skip ahead to 3. You should run it for each one, but I'm just showing you how to run for some of them. So this is with no gap, right? Should that cause a problem? Well, let's see here. There actually is technically a gap because numerically you generated a finite amount of data. So there's a max value, there's a max x value here for which this is negative 1 and a min value for which it's 1. And they are separated by some non-zero value because numerically you have a finite amount of data. So even if you say that there's no theoretical gap between these two classes, numerically there will always be a gap because you're never going to randomly generate a point that's right on the boundary. So there will always be a small numerical gap. So then technically everything should work for the perceptron, even though theoretically there's an issue, numerically there's not. But notice even at one epoch now, this is a very small gap. One epoch seemed to be enough when there's a large gap. We're able to just nail it with one epoch every time, even as we switch initial guesses and switch learning rates. But here with this, we're getting not enough, and we have to, let's say, increase to 12. Yeah, I would say there's still some misclassification even at 12. It's 2.49 and negative 1 for those. Let's see what happens if I go up to like 47. Maybe there is no misclassification. Maybe that's just a graphing issue where that point is. But it seems, let's see if I adjust it just a little. Yeah, I'm not seeing that it's getting any better than this. So there seems to, I would say at this point, it's just stuck there. Like this, it's not moving from this. That's with the x data 3. Like if you go to 2, let's go ahead and run that. And you should do this in new code cells. I'm just doing this for the sake of illustration. Same issue, right? So again, here at 1, there's some misclassification. That one looks to be misclassified. If we go to 2, let's say just, all right, like 2 iterations, press enter. There we go. Now we're in interact. 2, I don't think that did much. So go to like 29. It doesn't seem to really be doing any better. This is with that x data 2. That's with that small gap. And then if I wanted to look at, again, you should create new code cells, but I'm just going to edit this. So with 10 data points, let's do 4 that has the small gap of 0.01. If I do 4 here, and I do 4, and I run that, and I run interact. Okay, yeah, this is the thing when I've just created enough figures that it starts to get a little mad at me. So I'm just going to run it again just to get rid of that warning. So look at what happens when you have less data. It didn't do as good of a job. If you have a lot less data, it takes more times to go through the data to learn something because you just have not much data. Before we had 100 data points and it kind of was nailing what it wanted to do right away or without that many epochs. But if you have less data, it takes longer to learn because you have to kind of just go through the data over and over again. So that's with 1 epoch. Let's go to 4. Look at 4. It still doesn't have it at 4. Like that was unheard of when we had the 100 data points, even with any of these gaps. It seemed to pretty much get it after 1 or 2 like epochs, even with some bad initial guesses. And I'm not changing the learning rates, all the things I'm asking you to do. I just want to give you a sense of what's going on with the sensitivity to your choices along with the training data size. Like the training data size seems to matter a lot more than the gap size. If you have not much data to train on, it takes longer to learn. Right here, this is 4. Let's see what happens when I go to like maybe sliders. Maybe I should adjust the slider so it's not so crazy. So let's say let's go up to like 10, just so we have a little bit more control. So here's at 1 epoch. Let's see what happens when we go up to, let's say, 7 epochs. At 7, it got it, right? It's nailed it at 7. And that might have even happened at 6. At 6, it was there. At 5, it was not. So it took 6 iterations to get it here. Now, this is with the kind of the small gap, but you can still see there's, the small gap numerically becomes maybe a little bit larger because of the finite amount of data and the small numbers of data we've generated. If you were to change this to so that was X data 4, X data 5, and Y data 5 would be the larger gap. So let's see what happens there. If we change to 5 and to 5 and we run this, we run interact. So here's that 1 iteration, and it's just terrible. It's moved in the wrong direction from what it's learning. If I go to 2 epochs, so I go through the data twice, it's just awful again. It's not learning anything. In fact, I need to, it'd be better to shrink this down a little bit in terms of the size of the figure, but that's okay. I'm just going to keep going. 3 epochs. Okay, it nailed it at 3, right? So it took less epochs to figure this out because there's this bigger gap. But before it was 1. We got it in 1 every time. And as we were switching the WB and the R even, we were getting 1. And you could say, like, what happens if I shrink this learning rate down? And I have a small number. So it's like, I'm saying I want to adjust a smaller amount. That's what kind of a smaller learning rate is. I want to be conservative in how I'm updating. And I don't have much data to use to update. So what happens if I shrink it down from 0.5 to 0.12? Look, it's still not there at 3 iterations. What about at 5 epochs through the data? Still not there. What about at 6? Still not there. 7, 8. Let's go to 8. Okay, at 8 it got it. At 8 it finally got it. And at 7 it got it. So it took 7 this time. So it took more. And you could play around. You could adjust, you can make these initial guesses kind of worse, right? And you see you just get different values, and it really skews where it changes the difference in like what it's learned. And that's with that small learning rate again. With this better, I guess these W and B values are a little bit better guesses. And so then if you have a better initial condition, you can converge really quickly. But if you have some bad value, you're not converging quickly. You're getting some other value. So these are all things to play with, and with the learning rate, and with the number of training data, and with the size of the gap. It's just lots of things I want you to play with and build some intuition. And you do it for like data sets like this. And then after each one, you might want to just add a markdown cell above it that just summarizes, your findings. Just write down kind of, this seems to be what happens when I play with these values of the weights, the initial guesses of the weights and the bias, and vary the learning rate, or compare this to like what I see below, where I use the same size gap but less data or more data. These are good things to just play with. This is all I'm basically asking you to do up here across all these instructions. So that's it for this video. Thanks for listening. I'll create another video for the second activity.